Hello everyone! Welcome to another Firebase Deep Dive. This month we'll take a deeper look at Firebase A/B testing's updated inference approach. Firebase A/B testing helps you optimize your app by trying different user experiences and measuring if they improve your key metrics. Until last month, Firebase A/B testing used Bayesian inference to choose an experiment leader. Now, A/B testing employs a Frequentist approach. What's the difference? In very simple terms, Bayesian inference considers observed data and predicted future behavior to choose an experiment leader. Frequentist inference, on the other hand, uses only the observed data to calculate the likelihood that your A/B test results will remain true in the future. It uses a probability value, or p-value, and a confidence interval that indicates how likely it is that your results are repeatable. We'll talk a little more about this later. Now that we understand how this new approach works, let's understand the benefits. Because Frequentist inference uses observed data and not predicted data, you can independently verify its results. No need for a crystal ball to divine why the algorithm selected a winner. When sample sizes are small or results aren't evenly distributed, Frequentist inference is less likely to provide misleading results. And best of all, Frequentist inference provides a quicker result. No more waiting 1 or 2 weeks. Leaders are declared as soon as we detect them. So let's put it to the test. We'll open the Firebase console and create an experiment. Imagine you want to increase purchase revenue by rolling out a promotion. So you create an A/B test with 2 variants: the baseline with no promotion and the variant, which shows a promotional banner. While your main goal is to increase purchase revenue, it's a good idea to track crash-free users and user retention to ensure the change doesn't reduce your app's stability, or even worse, cause customers to churn. Here's the experiment setup. Now let's start the experiment. After running the experiment for a few days, open the Firebase console and check the results. Here you can see that variant A outperforms baseline and it's statistically significant at the 95% confidence level, because any value of 0.05 or less indicates that the lift probably wasn't caused by random chance. Now let's take a look at the confidence interval difference of means. This provides the range of expected lift values at the 95% confidence level. In other words, if we run this A/B test 100 times, the lower value represents the lowest average difference between the variants, and the higher value, the highest average difference, for 95 out of 100 tests. For variant A, there's an increase in average revenue. This is a very meaningful lift, so you can feel confident that the promotion increased revenue. But wait, before we roll the banner out to a wider audience, let's check in on the secondary metrics. First, let's look at user retention. A p-value greater than 0.05 means the change isn't significant. Crash-free users show a non-significant p-value too, so the app is stable. Given the revenue increase and no meaningful change in stability or user retention, you can confidently roll out the promotion to your entire audience and start increasing your revenue. Thanks to Firebase A/B testing. From now on, when you run a Firebase A/B test, you'll see your results with Frequentist inference. Your older experiments will continue to run with Bayesian inference until they're complete, and their Bayesian results will continue to be available for you. To learn more about this change, check out the A/B testing documentation and this post on the Firebase blog. Both links are in the description. Thank you so much for watching, and I'll see you in the next episode of Firebase Deep Dives.